In this paper, we present Artemis, a novel neural modeling and rendering framework for generating articulated neural pets with appearance and motion synthesis, which supports interactive motion control, realistic animation, and high-quality rendering of furry animals, all in real time. Further, we extend Artemis to OpenVR for supporting consumer-level VR headsets, providing a surreal experience for users to intimately interact with a variety of virtual animals as if in real world. In the past, digitization of fascinating animals such as Aslan the lion in the Chronicles of Narnia to Richard Parker the tiger in Life of Pi brings close encounters to viewers, unimaginable in real life. Despite huge successes in feature films, accessing computer-generated imagery, CGI, digital animals and subsequently animating and rendering them at high realism have by far been a luxury of VFX studios, where the process of creating them requires tremendous artists' efforts and high computational powers, including the use of render farms, which is far from real-time interacting with the animals at high realism. Previous works set out to address the challenge from animal motion synthesis side and scene rendering side. The animal motion synthesis works, such as local motion phases achieve generating natural animal motion in real time without rendering animals' fur. While recent neural rendering-based approaches achieve high-quality hair and fur appearance rendering with opacity generation, but they are designed for static scenes, and are still far from real-time dynamic animals rendering. As for dynamic scenes rendering, the recent works can however not generate high-quality appearance with rich details, which is especially essential for dynamic furry animals. We address such challenges in our Artemis system by two core components. In the first module, given skeletal rig and skinning weights of CGI animal asset and corresponding multi-view rendered RGB images in representative poses, we build a dynamic octree-based neural representation, called animatable neural animals, to enable explicit skeletal animation and real-time rendering for dynamic animals, which supports real-time interactive applications. In the second module, we build a hybrid animal motion capture system with multi-view RGB and Vicon cameras to reconstruct realistic 3D skeletal poses, which supports to training a neural motion synthesis network to enable a user to interactively guide the move of the neural animals. The Artemis system is further integrated into existing consumer-level VR headset platforms for immersive VR experience of neural-generated animals. As for our animatable neural animals, given multi-view RGBA images of traditional modeled animals rendered in canonical space, we first extract a sparse voxel grid and allocate a corresponding feature lookup table as a compact representation, together with an octree for quick feature indexing. Then we pose the character to training poses using the rig of the traditional animal asset and conduct efficient volumetric rendering to generate view-dependent appearance feature maps and coarse opacity maps. We next decode them into high-quality appearance and opacity images with the convolutional neural shading network. We further adopt an adversarial training scheme for high-frequency detail synthesis. In our hybrid animal motion capture system, we use 12 Vicon cameras, with 22 cinema cameras evenly distributed surrounding the animal subject. Cross-calibrations and synchronization are conducted in prior of actual motion capture. Using this animal motion capture system, we acquire a new animal mocap dataset along with a deep animal pose estimation. We estimate the animal skeleton, small parameters more specifically, from the multi-view video data and Vicon mocap data. Based on our captured 3D animal skeleton sequences, we leverage the recent advances on data-driven methods in human movement animation, i.e., local motion phases, LMP, for our animal motion synthesis, to learn movements from asynchronously behaviors of different body parts, to further enable interactions between the user and the virtual animals. To demonstrate the performance of rendering high-quality photorealistic furry animal images and corresponding opacity, we mirror our method with neural opacity point clouds, neural radiance fields, and convolutional neural opacity radiance fields. Our approach outperforms other methods in both appearance and opacity rendering. We further compare to state-of-the-art neural rendering methods for dynamic scenes. Our methods can model high-frequency for appearance and geometry details and generalize well on both novel views and poses. Our first demo shows a scenario where the user would be able to view the vivid virtual panda in VR headset in the real time. We can clearly see the fur of our neural panda in this video clip. The second demo shows the case when real-time human markerless motion capture techniques are used, how the high-level control signal given by users are used to interact with our neural pets. The user gave commands by pointing at a certain location, circling in the air, wave hands and so on, to control our neural pet. The last demo presents the scenario of implicit control. When no users are present, the pet would freely explore the environment by themselves. Thanks for watching.